The next classifier to consider is the naive-Bayes classifier. This classifier is based on the theory of probability. For an unseen document represented by D, the model has to identify the probability of each of the classes given this document. In case there are three classes, so what is the probability of C1 given the document D, what is the probability of C2 given the document D, and the same way what is the probability of C3 given the D document. Among all these probabilities, the class that has the highest probability given this document has its label assigned to the unseen document. It has been evaluated with the formula given on the right side. It is combination of the likelihood that is evaluated as the unseen document in the training data, relevance of the unseen document in the training data with each of the classes available. This is the prior probability and is the probability of the class in the training data. If all the classes have equal proportion in the training data, it's going to play a uniform role. Although if it is differently proportioned, then this is going to support the dominant class. At the denominator, we have the normalization factor that counts for the relevance of the unseen document with the documents in the training data, and it's going to have the same impact on all the labels, and therefore ignoring this is not going to make any difference. As we know that a document has a list of features and cannot be represented with just one value. Therefore, it can be elaborated as this: what is the probability of the first feature in the document D given a class? What is the probability of the second feature given the same class? And then for all the labels, and it's being multiplied, and it gives us the probability of that class given a document, and then the same is being repeated for all the classes. It's also represented over here in this way, where dj iterates through all the features given a particular class ci, and then all the values are being multiplied. However, there are some problems associated with this approach. If a feature has got a value of 0 for a given class, the whole values being multiplied are going to be 0, and everything is going to be 0. In that case, the model is not going to be very helpful, because we know from the text representation there are majority of zeros in the representation, and therefore most of the classes will have 0 probability for a given document. Therefore, in order to address this problem, a smoothing factor can be used that adds a small value in case the value is 0. Another problem associated with this approach is that the probabilities are less than 1, which means it's a small value, and when it keeps on multiplied with multiple other small values, it gets smaller and smaller, and therefore may cause the underflow error. In order to address this problem, we can also use summation on the log of these values. So the probability of a feature dj for a class ci is being calculated and is converted into its log value, and all the log values are added, and it gives a particular value. With this, we have transformed the values from probability value to log of probabilities. However, the information is not being lost, and the class that has the higher relevance would still be represented high probability.